I want to show another way that you can use conversions. So this particular problem doesn't have a metric chart that's necessary or another conversions chart. This is actually a density problem right here, density. So you could use, D is equal to M over V. It wants us to solve it for V and then rearrange it and solve it. But I want to show you another way that you can use factor label. Instead of trying to rearrange those letters, you could start with what has 1 unit. See how this has 1 unit? This has 2 units, so this is a conversion. It's kind of like something you would get off the chart. What this means whenever you see it is anytime you see like a division or, like something that looks like a fraction, this means that 2.0 grams are divided by 1 liter, because when you divide by 1, you just get itself. So if you want me to write it so that it's equal, that's also like saying there are 2 grams in 1 liter. If something weighs out 1 liter, there are 2.0 grams of it. So here's how you'd solve these kinds of problems. You start with the thing that has 1 unit. Again, 1 unit, 2 units. Start with 1 unit. You're trying to solve for liters. 3.0 grams. You got to get rid of grams, and it wants you to get 2 liters. And then you look over here and you say, oh, I've got that conversion. It's right here. There are 2 grams in 1 liter. So 2.0 grams in 1 liter. So when we solve that, it's just 3.0, times 1 divided by 2.0. And that gives us 1.5. That's good on the sig figs because this has 2 sig figs. This has 2 sig figs. This is exactly. You don't ever use the ones in these conversions to figure out sig figs. If you try to use a 1 to figure it out, then what will end up happening is every single conversion you do will have a 1 somewhere, and you'll always end up with 1 sig fig. You don't want that to happen. So these ones are exact. You can call them placeholders, whatever you want to call them. They are exact, and the 1 part of this is. And you don't ever have to include those for counting sig figs, but count things that aren't 1, unless, again, it's exact. So this has 2 sig figs, and then my unit here, notice that my grams cancel, so my unit is liters. And here's another example. This one wants it to go to grams. This has 2 units. Don't start with a thing with 2 units. Start with a thing that has 1 unit. Milliliters. Now, this has 1 extra step because this is going to take me 2 liters. So I can't automatically just put this one in. I have to use information, remembering that I can get from a milliliter to a liter. That's a base unit. So you can always get to the base unit using the metrics chart. I'm going to throw my liter down, and I'm going to throw my gram in there. I'm going to double check that it'll all cancel out. Milliliters to milliliters. Liters to liters, and then all I have to do is just fill in. I'm going to put that gets the 1, and that's 1 times 10 to the minus 3. And then here 1.5, and remember when there's not a number on the bottom but there's a unit, we just say that that's the same thing as 1. It's like saying 1.5 grams is equal to 1 liter. And then I just have to throw that in, 0.1 times 1 e to the negative 3 times 1.5 divided by 1 divided by 1. So I end up with 1.5 times 10 to the minus 4. Let me double check my sig figs. Look, this just had 1 sig fig. This is exact, and this had 2 sig figs. And by exact, I mean that whole quantity is exact because it's all in the same metrics chart. So I actually would round this to 2 times 10 to the minus 4th grams, because that cancels and that cancels.